My voice is audible?
Yes, ma'am. Yes.
It is my pleasure to introduce our esteemed guest, Professor Jonathan Chan. Professor Jonathan Ed Chan is working as an associate professor in the School of Information Technology, King Mongkut University of Technology, Thonburi, Thailand. He is also the advisor for global engagement. He is currently the president of Asia Pacific Neural Network Society. Professor Chan has completed his BSc, MSc, and PhD in the year 1984, 1986, and 1995 respectively from University of Toronto, Canada. Please let's welcome Professor Jonathan Chan for his enlightening hands-on session.
Hey, hello everyone, can you hear me?
Yes, sir.
Okay, great. So good evening, greetings from Bangkok, Thailand. My apologies for not able to travel there in person this time. I had a little bit of a passport. My passport is full and I cannot get it in time because I have to keep the current version. So anyways, I'm hoping to maybe come by later this year to hopefully meet you in person. So it's getting late here, so I think I'll just get started. I also have some of my intern students here with me. They're just sitting in front of me, actually. I'll show them to you later on. So for this session, we're going to get you a little bit of hands-on to be on the Kaggle system. So if I can get, if someone can either type in the chat or maybe have a reaction showing me if you have experience going onto the Kaggle platform, Kaggle. If someone just put in the chat, just say yes, or you can just have a reaction emoji or whatever. I'm just curious, how many of you have actually signed up for Kaggle so far? If not, then you'll be doing it now. Okay, so we have at least one person who has done it, so that's good. So I just can help others who doesn't have an account to sign up. Okay, so what I'll do is I would share my screen. Here we go, share. Yep, whole screen is fine, and share. Right, so it's just, you go to kaggle.com. It will look something like this. If you do not have an account, please do register. And when you register, you can register with Google or email, whatever. And the thing is, if you want to compete in a regular competition, their prize monies, then you need to link it with a real phone number. So currently, I think you can do it by just registering with Google first. That's probably the easiest if you don't have an account. Anyways, I'll give you a few minutes to do that, and let me just go to my profile here. So I logged in another browser. And let me just go over some things here. For those of you who might not be familiar with Kaggle. So this is basically a competition platform for data scientists that's started some 15 years ago, 15 years or so ago already. And the features are on the left here, competitions. You can post data sets. You can now, one of the newest ones is models. You can create different models and upload it so people can actually, I guess, use your model as code is mostly in Python or R, using what's called Jupyter Notebook, the interface. And then discussion is for forum, people posting messages. And the one for the beginners, for those of you who would like to learn more, is to learn. Actually, I should show you the other one. That would be courses or learn. And let me just make this a bit bigger. Okay, so all of you should have no problem with programming, and I expect all of you should have some knowledge of Python. And you might have started with Introduction to Machine Learning. Let's just take a quick look at it. So the idea here is, it takes about 3 hours. It says, learn the core ideas in machine learning and build models. So this is the hands-on part. So you have a very good lecture from Professor Shusmita just before this. And I believe you have some background in this area already. If not, then you'll be building it up slowly throughout this summer school. So this micro module is called, has different lessons. First, talking about modeling, and then basic data exploration. We actually call it EDA, exploratory data exploration, or sorry, exploratory data analysis, EDA. And then you'll be doing your first machine learning model. You would validate your model, and then you will address the issue of overfitting and underfitting. And finally, random forest, and introduce you to some machine learning competitions. Let me go through this very quickly because I would expect that most of you already have good experience in this already. So I'll just go through this relatively quickly by switching to my profile. And if you notice, I never completed this course because I was just giving, I guess, pointers, and then I just didn't bother finishing it. So, but to go very quickly, let me just go to the very first part, how models work. It's a tutorial and exercise. So I would explain to you about this interface. So when you click on how models work, you will see that you would have different tabs, like tutorial tab and a data tab. So this is in form of a Jupyter Notebook. So the tutorial basically is the markdown language. So all of this is part of the Jupyter Notebook. You can write it in terms of text. So it gives you an introduction. So you can read this, go through yourself. And basically, the first thing you want to go through is something about real estate, about your cousin, and so on. So this is the first thing you would look into. Let me just make this a bit bigger. So the first model you're going to look at is what's called decision tree, which I'm sure that you all have experience with. And decision trees actually can be quite powerful. So it's a very basic model building block in data science. So something like this, if you want to look at real estate, you want to buy a house or an apartment, or maybe even rent an apartment. You want to see it, is there more than 1 bedroom, 2 bedrooms, what the price might be. So you want to make a prediction, in this case, what the price may be. So in this case, it's only 2 categories. Okay, so this is a binary tree because there are 2 branches. And it's a full binary tree. That means each leaf or each subnode would contain 2 branches as well. So those things you can go through yourself. There's some link here you can actually follow as well. So I'll try to go through this a bit more. Now, there are different decision trees, and you have learned about those. And it's a matter of what you put up here as your node. How do you want to split this? And the price you want to split at, and things like that. So there are different ways to design your decision tree. So I won't go into any details because you can read it here. Now just skip through. And then next, we're going to examine the data. So if you examine your data, you click on this link. And now just pause a little bit here to make sure that everyone's kind of following along. I hope everyone has registered already if you have not done so. And I believe most of you do have a Kaggle account. And if not, please ask your friend next to you to help you to sign up. Okay, so we're just going through the very first course, Introduction to Machine Learning. And this is the hands-on part. So we've gone through the tutorial, the very basic introduction. We're going to look at some real estate data, and then we're going to do some basic data exploration here. So the idea is we're going to load and understand the data. So I mentioned it's a Jupyter notebook because there's got both the markup or markdown languages, and also in here is a tab for data. So we're not going to start the exercise yet, but if you see data, it looks something like this. So on the right here, it says, okay, some other, you may be more used to the one on Colab, for example, the data sources on the left-hand side, but for Kaggle, it's on the right-hand side. So it tells you there are 3.43 megabytes. Under this data source, there's housing price, competition, the different files. You can click on description, for example, you keep your description here. If you want to look at, say, the training file, CSV, comma separated value, then you get something like this. And it describes to you the different columns and so on. Okay, so these are the things you'll be seeing. We'll be looking at some of these in this. So very quickly in tutorial, let's just go down here. So basically it's in form of a Jupyter notebook. You got text and you have the code. So in the code, it's under different lines. This is 1, next one is 2, and so on. So this is in Python. So we want to import pandas, and we call it PD for short. And this is to handle basically the data frames. So the data that I showed you earlier, for example, here, when we look at the training data, it's like a spreadsheet, right? You get it from the Excel spreadsheet. And a data frame is basically a spreadsheet. It has rows and columns. And the column can have different types of data. It could be integer, it could be categorical, it could be a text, it could be real numbers, and so on. So that's a data frame. So the terminology we use here is called data frame. So it holds the data that's in the table form, like Excel. All right, so next we're going to basically set the path as to where this is. So this is the instructions given here. And then we're going to do a description here. So we just used we created this variable called Melbourne data. We're reading it in using pandas from this path, which is basically here. In quotations, the path, which is actually Melbourne data here. And then we would, okay, let me show you later when I go into tutorial. Okay, so I think you're familiar with this. Let's just skip through this for now and go to your turn. So now we can start entering codes. Let me make this a little bit bigger, like this. I mean, covers wider coverage. All right, so I call it IC2 intro tutorial. Yours is different. I mean, you should say introductory. So this is an exercise I was giving to the interns as well. We have some summer interns here this summer, both from abroad and also our own interns from our computer science program. Anyways, So now, the first thing it would do is you will call this library called Learn Tools, which is from Kaggle, which has all the modules for learning. And in particular, it's going to bring up this one, EX2, and it would just bring everything up. So you're going to run this. So to run this Jupyter, it's a Jupyter notebook. So it's in Python code. And what you do is, right now, let's just do this for now. You can run the code by clicking on this little triangle here, execute a code. Or you can execute from the top here. So what it do is just waiting for Jupyter here. You start setting up a session for you. So once it's set up, then it's pretty fast. But it will take maybe a minute or so, depending on. Okay, now it's complete. It says setup complete. It's printed complete. So next, we will load the data. We're going to specify the path. So the path here is, in this case, data for ML cores. So here it says copy file path. So we're going to click on this thing. And if you go over here, you can do a paste. Right click or just Control P. Maybe Control P then. I'll paste out. Okay, paste. Oh, okay. Never mind. Just use Control V for pasting. Shortcut Control and then the V key, keyboard. And this is same as this. So basically, that's what it's done. We put it into here in quotations. We'll say that's the path. And then we will say this is from. For some reason, it says Iowa directory. It's a state in the US. Then we're going to say plus train CSV, or you can specify the whole path here. So there's no right or wrong way. You can, if you want, you can do this, copy this, and then you can put this, highlight it, put it in quotations, and then Control V. That also works. And then now we're going to run this. So you can run the one on here, it says run current cell as well. And it says correct. So now if you're stuck at any point, you can go to hint. You can undo the hint and undo the solution. Actually, everything is here. So that's not a problem. Okay, so you can follow through this if you're stuck. Let me just go down a little bit on the reviewing this part. We don't need any hints because we've already done that. Now, let me just run this again. So you'll see that this data we have, this ID, this MS subclass, there's a loft frontage of the house, area, and so on and so forth. So all of this is given here, describing it, the number of them, 1,460 in the training file. The mean value for each one of these, standard deviation, minimum, first quartile, second quartile, third quartile, and the maximum value. So that's from describe. So you can refer back to this when you have to do your own coding. I mean, actually in the previous tutorial. So now what I've done is actually I've done beyond that in my example here. I'm actually creating a date time and I'm just coding it. So how complicated you want this is up to you. If you just follow the solution that's given here, it's very straightforward. And then you can, if you're more experienced, you can challenge yourself and create a bit more. For example, you can put things like date time. You can create things like the date. The newest home should be the one that's the newest in terms of closest to today's date. For example, you can create that. You can create this yourself rather than reading. The minimum requirement here is to reading from this. Year built. You want to find the newest home, that means maximum. That means 2010. You can put in the number 2010 and that's fine, 2010. You can put here. And that will work. Oh, maybe not. It's not 2010. All right, then maybe I was wrong. If we do this, then it's correct. But it should be 2010. Oh, sorry. Minus the today's state minus that. So for right now we have 2024. So it should be 2024 minus 2010. Okay, now it's correct. So that's what you expected to know, very minimal. But like I said, if you want, you can put in things like this or whatever you like to do. So you can code it if you're more experienced. Okay, even though it's a very basic module, you can challenge yourself to come up with more creative solutions if you like. And the goal is that you want it to be correct. So anyways, it's doing this and so on and so forth. Again, go forward with this. Okay, so now you're ready for your first machine learning model. I'm trying to go a little bit faster because I'm pretty sure most of you are familiar with this. So now we're going to look at data from Melbourne, Australia instead. And in this case, there are different columns like suburb, address, rooms, types, and so on. So you can follow this, Now here we introduce something called drop not available or drop NA. So what that means is you have to look at when you have a data set, the first thing you want to do is for your exploratory data analysis is to look at whether or not you have missing data. So for example, if there's NA in part of your data frame, you want to remove it, or you want to maybe replace it with another value, because otherwise you will have problem processing it depending on which kind of model you're using. Some models have no problem with not available, but most models will have problem. So standard is that you would actually remove the not available or NA. Okay, so you can go through this a little bit more detail yourself. For those of you who have not completed this yet, if you have completed it, like I said, you can challenge yourself and create a more interesting notebook you can showcase. All right, so I won't go through this because you can go through this yourself. And I trust that you already have some experience. And one of the things you will be going through is the scikit-learn library. We'll be using that, or sklearn. So the steps to build, I just emphasize this a little bit. Let me make this a bit bigger. First, it's define what type of model it will be. And that would depend on what type of data you have. So actually, before this, you need to have some understanding about your data. So if you go through this, it will talk about data in exploratory data analysis. So first thing is understand your data. Then you try and define what type of models you want it to be. Decision tree is the first one we're going to build, I believe. And then there are others like neural network, random forest I mentioned, which is basically ensemble decision tree, and others as well. So right now with deep learning, of course, the focus is a lot more and more on neural networks that has 3 or more layers. So the other thing you want to do, once you define it, you're able to fit it. You want to create a model based on, we're using supervised learning. That means you know the ground truth, the label. You have your input data, and as well you know the label, which could be categorical, for example, yes or no, or the first thing I'll provide to you for the hackathon is actually the digit recognizer. It's the handwritten digit. You can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in Roman numerals. And that is called the hello world of basically the first program you would use for computer vision. Okay, so fitting it, and then the prediction is actually what you like to do. You want to predict unknown cases. And then you want to assess, evaluate how well you have done with your prediction. Okay, so a very simple one is like this. From scikit-learn, and we're going to use a tree model. We're going to import decision tree, and we're doing regression here. So it's a regressor. Otherwise, we call it a classifier. So there are a whole bunch of parameters. So what you can do is, for example, if you want to know more about this, it's very simple. You can just copy this, create a new window, and just paste and search. Usually the library comes up scikit-learn. Or you can use ChatGPT, whatever you're comfortable with. So now this tells you basically what are the parameters for decision tree regressor from scikit-tree. So the only one that's given there is just random state. And if you want, you can say ChatGPT, obviously, for many of us, just for fun. You can go start now because you don't need to sign in anymore, and I don't sign in. Now stay logged out and say, what is, whoops, random state. Actually, I can ask the whole thing and see what it answers. Okay, so basically, it's a parameter that's used to initialize a random number generator. So it's exactly what you expected. But ChatGPT's answer for basic questions like this are very good. Okay, so all right, so we're going to use the regressor, then we're going to fit it to our data, X and Y. And then we're going to make predictions. Okay, so you can go through this, your turn going through this. And like I said, it's not that complicated. It doesn't take very much time. And I'm going to throw you into the fire and say, because I assume you know all this. If not, someone next to you is familiar with this. So I'll skip all of this. And I'll just go skip. And keep going. So now this is to build your model, which we have done and do the prediction. We have gone through the tutorial very quickly. And then we're going to do model validation. So this part, you're measuring the performance of the model that you have just created or built. And you want to test and compare it to other models. So for those of you who are doing projects or you with interest doing a research project in particular, then what you should do is you want to compare alternatives. This is part of the research that you do. And even in competitions, you want to compare to alternatives because you want to build a better solution. So better is a very vague term. It can mean different things. So with experience, you would know what better is to you. And I'll try to provide some insight as to what you can do for some of these couple competitions. Let's see if we can go through this quickly. All right, so model validation, you follow through this. And one of them is, for example, for regression, we'll look at mean absolute error. Or mean standard error, or sum of square error, whatever. So there's standard, I guess, measures we can use for this. So this is basically, so for this one, we're using MAE, mean absolute error, which is the difference between your prediction and the actual value, the difference, and the absolute of the value for that. Very basic. Okay, so you can import this metric actually from scikit-learn directly, and particularly the library metric of scikit-learn. So coding it, first thing you could do is splitting into train, test, just two. Training, you use it for train because you have the labels, and then the test ones to see, you want to evaluate how good is your model. It's a very basic, but most of you probably know also that you would go to, instead of doing just train test split, you would use cross validation. For example, 5-fold, 10-fold cross validation, depending on how large a data set you have. Okay, so here we can import very basic train test split. And you can go through this decision tree regressor, you can do all this, and wow, you can actually come up with a solution. There will be a prediction. Now, model validation is this. So next, you go through the notebook yourself. So now this is a Jupyter notebook. Again, you have markdown. These are markdown text. And then code will be the one that's shaded. It's the code that has comments and things like this. Now, if you're not familiar with, not very familiar with Python, it's very easy for you to just ask ChatGPT about any question. And what some people have done is basically taking published code and they explained it using ChatGPT. And they organize it in a nice way and explain it. They can actually post this and upload it, and people actually upvote it and say, oh, this is good work. I enjoy it because he's trying to explain to me. So things like that you can do. And ChatGPT or large language models can do that quite well. And you'll be getting more about large language models later on in this summer school. I'll just go and mention it, and I'm sure you're familiar with it, but I'll mention a little bit more later on as well. Anyways, so going through all this, you can split the data and so on. So basically, that's what we're going to do. And we'll fit it, and then we'll make predictions. And we can actually calculate the value ourselves. So this is the metric you're going to use. So this is, I haven't completed this, but if you're stuck for some reason or you want to be in a hurry, you would just undo, this. Whoops. And this to get Handson's solution if you really in a hurry. But then you probably want to go back and learn things properly at some point. Anyways, so that's what it is. Let me just go over underfitting, overfitting, because there was a question earlier for Professor Shishmita and asking about how to avoid overfitting. So overfitting means you're fitting too much to the small patterns, the nitty-gritty about your training data set. That means you will likely not be able to generalize well. And in the competition that I'm going to show you, we have started 2 Kaggle competitions just for DLAI8. We decided to launch it just before I was talking. That's my entrance to start it. So it's actually running. I'll introduce it to you. If you cannot wait, then you just go and search for DLAI8. Then you'll find the 2 competition launch already. You can start on that for those of you who are more advanced. Okay. So if you're more advanced, you can just go ahead, go to those 2 competitions and start working on it and submitting. For the rest of you, if you want to follow along, then we're going to go through this. Okay. So overfitting is where a model matches the training data almost perfectly. But it will be poor in validation and other new data. Okay, so, let me just go to competition new. Let me just go to new tab. I do show you now. So if you type in search for DLAI8, you'll see the 2 competitions here. two teams already submitted for this one and this. So this one, the porosity challenge is for regression, like the one we just gone through with the housing, with the house prices. The second one is basically digit recognizer, like I mentioned earlier, the hello world. It's handwritten digits like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to recognize a handwritten digit. So it's a classification. So the regression and a classification problem. So I'll put these two in a tab. And then I'll come back. So overfitting. So I believe you understand what overfitting means, most of you, and you are trying to ask how to get around or how to address the issue of overfitting. So let me go to the Kaggle competition on digit recognizer, which some of you probably have gone this. If you have done this already, your notebook would work almost exactly for this challenge. There's some changes you need to modify. So if you're already advanced, you can try to use your notebook, or you can use share code here. So on Kaggle, in this competition, you show the overview of the competition, which is based on MNIST, the Modified National Institute of Standards and Technologies. It's a 28 by 28 grayscale image that's handwritten digits from 0 to 9. And it comes from Jan LeCun's group, one of the godfathers of deep learning. And if you click on this, actually, quite interesting information. This is where the website hosting the data set, which is all here, but it's also in many databases now. In scikit-learn, in NVIDIA, in many other databases, they have this in there, so you don't have to download it. Anyways, if you scroll down, it tells you performance for linear classifier, for k-nearest neighbor, boosted stumps, nonlinear classifiers, support vector machine, neural network, the basic ones. And then convolution, which is doing better, but then a sixth layer here is actually quite good, 0.35. It's better than some of these convolution ones, actually most of them. Except for this is actually done with an ensemble combining. So you can see here the best solutions around 0.23, actually, no, sorry. Yeah, 0.23. And best neural net is 0.35. And if you scroll up, you see for k nearest neighbor, using what's called shape extraction here, you can get actually very competitive score. This was discovered back in 2002 and 2007. So these are very competitive to the more complex neural network models. So this is, you can ask ChatGPT, you can do your own research and find out why that is the case. And also the references are here. You can click on this, you can actually go to the paper. So this is by a group in Berkeley who worked on this. All right, let me just go back here. So the data is very straightforward. The data is given to you in CSV file. So even though they're images, but they already mapped it or transformed it to be intensity of the pixel value. So it's 28 by 28. So let's say this is 28. So 28 pixels across, 28 pixels down. And it goes from left to right and then top to bottom. So when you stretch this out, 28 by 28, you have 764 features. And each one has a number between 0 and 255. So that's what's containing in this pixel 1 to pixel 784. And the last column is the label. Is what is the ground truth? Is it 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9? As simple as that. So this has been transformed into a tabular form. So you can use SS and you use tabular solutions like random forest, very popular. Right now you're using light gradient boost, XGBoost, and cat boost. All of those would do very well, quite well actually. But if you want to do better, you can transform this back to a 2x2, like 28 by 28 image. And you can use neural networks. Actually, neural network can be done on tabular. But then if you use convolution neural networks, you need to be an image. So you have to reshape it, change the 784 back to 28 by 28. So you have 28 across, 28 down. And then you apply convolution neural network, CNN. So I assume you have some background, basically like our eyes. We scan an image from one area going across and across. We scan a small area at a time. We don't look at the whole screen because we'll miss a lot of details. So when you're reading, you scan and you skip through like this. You skip through this when you're scanning. So this is basically what CNN does. Okay, so, and then let's look at the code. So what we're going to do is we're going to look at it here. We're going to rank it by public score. And you will see that many of them are 1, perfect. And these are perfect examples of overfitting. Because you can take these this notebook, for example, this one, it's got 128 likes and it's a gold medal. If we click on this, you will see the Jupyter notebook. So what you will see is that, oh, this one has 9.6, but one of these, if you click on this, different versions, one of them will give you a perfect score. Because if you give you a best score, but that's overfitting. So this current one is not overfitting. You might want to use this notebook. So what you can do is, if you want to use someone else's notebook, you would upvote it. You should upvote it. Then you copy and edit. You click copy and edit on the version that you like. So let's say I'm going to upvote this guy because it's got a gold medal anyways. And I'll upvote and I'll copy and edit this version. So you'll bring me to my Jupyter notebook. And then what I'll do is you can change the name. You can just change it to DLAI8 example, for example. Okay, so the other thing you should do, let me just, what I like to do is, let me go back to the previous one. I'm going to copy this link and I will cite this work because I copy from here. This is version 8. So now this is my notebook. What I'll do, I'll scroll down here and I'll go mark down and I'll create something. I will use sharp, do a little bit of formatting, and I will say taken from version 8 of, actually, this is the one. So that's basically, I was just referencing it. And what I'll do is edit, I'll move this cell up. So now that's at the top. So now I'll put this here. So I'm citing someone else's work because I'm taking it from there. So I give them credit, and then it shows you what it does. Okay. So from here, you can say on the right-hand side is the input. All you need is the competition data. You don't need any other data sets, so that's fine. Table of content, it describes you different subsections here. starting with summary. So summary, and then there's data input somewhere here, data input, and so on. You can actually go to that section by clicking on this. This is a new feature here, but I'm going to skip this. And then output is when you run it. So let me just come down here to session. Accelerator none, because it's a very basic model. But if you want, you can run a GPU or 2 times GPU if you need to have more memory. And actually, you need to compute something in parallel and faster than you use GPU T4 times 2. Or you can use Google's TPU, Tensor Processing Unit. This is actually faster for many of the code, but it's limited. You need to run it on the Google platform. We'll skip that for now. We'll just use none. And what I'll do is I was just going to run it as is. I will say run all. Okay, so it's going to run in the background. It's going to load things up and so on. Now, while it's loading, let me just go back to our competition. So this one I just launched. So if you have done that, I'll put in the chat anyways. I'll put these in the chat, make it easier for you as well. And then the other one. So these two we created just for you guys, for DLAI8, one regression and one classification. So now we're looking at the classification first, which is this one. Okay, just in case you don't have the link yet, or then you can just click on that. You can sign up. So what you need to do is you need to join the competition. Oh, because I joined already, so you don't. Let me just put it here. So you will see something like this. You need to sign in, and then you'll say join competition. Then you click join competition. Okay, so this is created by one of my interns, KM. And you can see in this case, we just created this just before this session, actually. We were just putting this together. I was going to show you how to do this. I'll go over with you very briefly. Oops. I'm just going to give credit to some. So this actually comes from Pupa. He's the one who working with one of his actually university spinouts. They have a data set that we simulated, generated. And so Pupa made this available, and KM helped to put together this challenge hackathon for you. For some reason, my name appeared first, so but we can change that later. I'm just in the background, should be. Anyways. So this is the regression one. Let me just go to the other one. Digit recognizer. So DLAI8 digit recognizer. So please join this competition as well if you have not done so already. Let's see if anyone shared their code. Not yet. No one shared a code yet. Okay, they're working on it. Someone's supposed to share their code soon. If not, I will share something. But we can use the one we have. Okay. So now we have, let me just go back. It was running, it should be finished. Where is it? Here, right? Yeah, this is the notebook. I think it should be finished now. So I'll check to see on the output. I'm going to click open this up and I'll click refresh. Is it finished? or maybe not. Anyways, so these are handwritten digits, examples 0, 3, and so on. So you can see from here, we reshaped it to be 28 by 28. And then we plot it. So this is how it looks like. So it's still running actually. So we're using a neural network here, very basic one. In this example, this from someone else, we're using a rectified linear unit, basically it's a not. So the thing is the activation function, which I believe you should be familiar with. We want to introduce non-linearity into the system, not just a linear system, so we can actually come up with a better solution. But to do that, the simplest way is introduce what's called rectified linear unit, which is basically the number by itself. I mean, x, you return x, unless the value is less than 0. If it's less than 0, you say 0. So it'll look like a straight line up to 0, and then it goes to x equals to y. So that's a nonlinear function because it's discontinued. And then it's using softmax because in this case, it's not a binary classification. There are 10 classes. You predict either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there are 10 classes. So we use softmax to give us a probability for each class. So those things, I think some of you already know about it. If not, it's easy to look up, and ChatGPT can definitely give you a lot of details. Anyways, let me just see where we are in terms of training. So we define a function using softmax. That's coding actually. Okay, loss functions is important. In this case, you actually coded it. So loss function is the difference between your prediction, which is prediction. Y is the independent variable, the prediction, and then the actual value. So you can define it in different ways. And in this case, it's looking at basically the difference is logarithmic, very basic. Let me just go down. Let's see what is it. It should be finished by now. Unless there's an error. Okay, it's just parameter initiation, gradient descent. Oh. Okay. Maybe I should have run GPU. So it might take a little bit of time. It's running through, okay, so this is actually a pretty good example for a coded solution. So most people would use existing modules, but this is actually good because they actually go through it step by step using backpropagation. So this is a very theoretical and implementing it based on the theoretical aspect. So this is actually a good notebook to have. So I'm glad I voted this guy, but I'm not sure how long it would take. So what I would do is, while it's running, I can file, download notebook. So it's called DLAI8 example for me. So I have this notebook. So what I'm going to do is I'm going to go to the competition we just created for you, digit recognizer. So we're going to generate a new notebook. So while you're inside, when you click new notebook, it will automatically, for the competition, provide you with the competition data here. So you don't have to import it. So what we're going to do next is we're going to, oh, it's a bit tricky. Okay, if you do this, okay, one thing you could do is import notebook. Then we're going to browse for the one that I just created, downloaded. open and import. So we're going to reuse existing code. Since I don't see any sample codes yet, so I'm just going to show you this. So the idea is, if you see similarity in terms of the solution that's open to the public, you can actually reuse that code for your work. So now you see actually, you change it to digit recognizer. It's not what I want. I should have saved it first. No, that's not a good idea. Um, okay, that was a mistake. Let me do it again. Oh, where did it go? Okay, I'm trying to file. All right, I'm going to open in Colab. A long way. I'm trying to, because Cargo, when you save a notebook, it saves all the environment. So I'll do it a long way. I'm going to go into here, Colab. I'll remove this Colab things. And then I would download this. Okay. Because I want to get rid of the formatting from Kaggle. Okay, come back to this. We're going to go to code. We're going to go new notebook. So I have DLAI8 digit recognizer here. Then go file, import. This time it should be okay. I should have picked a simpler one to run actually, but anyways. Oh no, it didn't work. All right, never mind. I have to save this as Python file. I have too many tabs open. There we go. File, download, Python. Keep. I have too many instances. I'll clean up later. Okay, so retaining this one, that's good. All right, so Python file works. So I'm going to remove these. So now the code is the same. Let's call it transfer learning, just for the sake of it. And come back to this. Where are we? Still not finished. Okay, anyways. So we don't need this actually. We start from here is import numpy. I guess I'll make it a little more complicated than necessary. I was trying to save this and then import it to this. You could do it from a text editor. For those of you who are faster, you can do that as a text editor. So basically, we're removing all of these. This is temporary files from Colab. Now I need to change the input. Train data is here. Test data is here. We lost the markdown language because I saved it as a Python file. It should be fine. So we can just, let me go to GPU. And then I can run and debug. Okay, just leave that running for now. Let's go to this, take a look at velocity challenge. Okay, someone uploaded the baseline. I think this is the, is that, this is Dylan. Is that based on a sample submission or based on what? Okay, well, look for the leaderboard. We have a leader. Ooh, pretty good. So we have a baseline. And, oh, now we have two baselines. I mean, two code shared. Anyways, so two of the interns have, my interns have submitted here, and you can see what they have done. Anyways, this is for you to look at. So we have opened up these two hackathon competitions until the dates are different. For this porosity is until 21st, just after the competition ends. But for the digit recognizer, where is it? Would be at the end of the competition, end of the summer school. June 20th, it's going in. So we'll see. No one submitted here yet. We will provide you with some sample notebooks here that you can study and try to improve upon. So what I was trying to say is, if you use the overfitted notebook, the one I use is not overfitted. Then if you apply it to the competition we have for DLAI8, for digit recognizer, your score would be quite low because the data we have is out of distribution, is different than the standard MNIST data. So if you use overfitting, then for sure your score will be much lower than others when you try to use it for that competition. Okay, so it's very late already. And so I think I better stop here. I don't think I should go on much longer. And if you like to, if you ask questions, you can relay the questions to the organizers if you want to reach me, or you can post. The beauty of this competition is that you can actually post questions here. There's discussion boards. So if you have any questions, please just raise it here. I would answer them, or my interns will answer them. And again, this is basically to challenge you to see what you can do for both regression and for classification challenge. So we introduced two challenges. We opened it just today, just before this session. And now, if you have signed up for Kaggle, you have joined the competitions, then you'll start seeing share code like these. Okay. And if you have any questions, or if you, for example, if you go to this notebook by Dylan, and if you like it, you can go to comments and say, you know, excellent work, if you like, and you can post. So I just posted it. Anyways, we can keep in touch here if you have any questions. Either in the notebook, if you want to ask question about the notebook from someone, or, you know, in discussion, you can just create a new topic and just say, hello, DLAI8. Feel free to leave questions, queries here, and we will try to get back to you shortly. Okay, so it's just a form. So you can, if you have questions, you can put it through here, or you can get the contact, my contact through the organizers. If you have something more direct, you can ask me instead. Anyways, it's very late, so I think I should stop here. I mean, it's very late here for sure. And it's getting late for in India as well. So I think I will stop here, and if you have any questions or any comments, I will take it quickly. If not, then enjoy the rest of the summer school. We have there's a jam-packed session all the way through until Saturday. So maybe at the final, on the last day, you will see who the winners are in this hackathon. All right, so I guess everyone's very quiet. You know what to do. I think it's very basic for you, my introduction, but at least we give you 2 competitions. Let's see what you can do. Let's see, and feel free to share your answers, ask for advice about anything about the competition, and then we'll try to answer you, and your friends will answer you as well. Okay, thank you very much. I think I'll stop.